Section 7.4, characteristics of logarithmic functions with base 10 and base e. I'm going to give a little disclaimer. I'm making this video at home and my dog is sitting beside me chewing loudly on a bone. So if you hear some gnawing, I swear it's not me, it's my dog. Okay, so logarithmic functions with base 10 and base e. What a logarithm means is if we take something, we take 2 to the power of x equals 8. And some of you will be able to solve this. But basically to solve it, another way we can solve it, we can put in our calculator log base 2 of 8. So 2 to the power of what gives me 8? And when we go to a calculator, and I'll show you how to do that here. I actually did it already. Let's erase that. On Desmos, when you first come to Desmos, it looks like this. If you go to show more, there's this log. So log base 2, 8. So 2 to the power of what is 8? And it gives me the answer of 3. So similarly, if I wanted to know 2 to the power of what is 256, I think this exists. Sorry. Log down here, base 2 and 256 is 8. So 2 to the power of 8 gives me 256. So that's what logarithm is. And it is also a function. It can be a function. So we're going to deal with logarithms when we have base 10. So it's like 10 to the power of what? Okay, and we're also, so that's log base 10. And we're also going to have base e. So when you have log base 10, sometimes people just don't even write the base. They just write log. And log base e, and e is a special number that's like 2.71. We saw something like that. And that is just ln. Instead of writing log base e, we write it in this way. So that's what we're going to be looking at. We're going to look at the characteristics of those functions. So I'm going to skip ahead to the key ideas down here. All logarithmic functions have the form f of x equals a log base bx, where b is greater than 0 and is not 1, a is not 0, and they are real numbers. All functions have these characteristics, whether it's log base e or ln, or just a regular logarithmic function. They have one x-intercept, they have 0 y-intercepts, the curve extends from quadrant 4 to quadrant 1, or from quadrant 1 to quadrant 4. The domain, all x greater than 0, and the range is all y greater than 0. Okay, or all y rather. All logarithmic functions in this form have these unique characteristics. If a is greater than 0, so if the number in front of that logarithm is greater than 0, it increases. If not, it decreases. Okay, so what I really want to get to is down here. We need to know the graph looks like one of the following cases. If it's increasing, or in other words, when a equals 0, this is what the graph looks like. Again, notice it goes from this quadrant to that quadrant. If it's decreasing, it's going to look something like that. And in fact, the graph of y equals log x is a reflection or an inverse of y equals 10 to the x. So this is the graph of y equals 10 to the x. To inverse something, you switch the x's and the y's. In other words, you draw the line y equals x. So remember, slope-intercept form. It has an intercept of 0, a slope of 1. And you just take each point and you reflect it. So this point's reflected there, reflected there. Each of those points is reflected. In other words, you take a point, so if the point was, actually let's find an actual point here. So let's say this point right here is 0, 1. We reflect that, we exchange the x and the y, and then on the other graph, on the reflection or the inverse, or log of x, the point is 1, 0. Okay? The graph of y equals ln of x is just a reflection of e to the x. So this is the graph of e to the x, and now we've just reflected it to the graph of y, to get the graph y equals ln of x. Okay, let's try some questions here. So, Randy came across a new type of function in his chemistry class, and those of you that have taken chemistry may have seen this. He learned that the pH of a solution is determined by a logarithmic function. He wondered how the characteristics of these functions differ from the characteristics of polynomial, that was last chapter, and exponential, that was the beginning of this chapter. Randy noticed that he had a log button on his calculator, so he looked into his user manual and discovered that this was base 10 logarithm. Using this button, he created a table of values and a graph for each of the functions below shown below to investigate the similarities and differences. Okay, so this was log 10. Notice it has a x-intercept of 1. This is 2 log 10. Still an x-intercept of 1. Only it goes a little higher afterwards. And this is 5 log 10, even higher, still a y-intercept. All of these are increasing. As we go from left to right, the values of y increase. At first they increase really fast, and then they slow down a bit. Increasing, increasing. Okay, so now it says use a graphing calculator to graph y equals log 10x and also y equals 10 to the x. Let's try that. Instead of just using this to get a real value, we're going to graph this. So y equals log, and if we don't put anything, it assumes 10. At least let's hope it does. Okay. Oh, Desmos actually wants me to write 10 in. That's interesting. Okay, and we're also going to do y equals 10 to the power of x. To do to the power of, I think, is right here, to the power of x. Okay, so again, we can see that they are mirrored images along the line y equals x. They're mirrors of one another. Okay. Oops. There we go. Randy choose 3 functions on a new screen, graph his functions. Well, we can see those right there. Examine each graph, state the following. X-intercepts, we saw that. Y-intercept, is there any y-intercept? Doesn't really look like it. It looks like we're getting close, but not quite. The end behavior, the domain, and the range. So the range would be any y value. Eventually, we're going to get any y value. However, the domain, the x values, you'll notice that we always have values that are greater than 0. So that's something different in this case. Are we increasing or decreasing? We already talked about decreasing, so we've got that. And then we would see the same thing if we've graphed ln of x or y equals e to the x. We would get similar things. So I want to skip ahead to a question, types of questions you're going to get. Predict the x-intercept, the number of y-intercepts, the end behavior, the domain, and the range. Okay, so these are actually going to be pretty simple. The x-intercept we always saw was 1. Okay, the number of y-intercepts, 0. The end behavior, well, it seems like they always went like this. So it seems like it starts in quadrant 4 and ends in quadrant 1. The domain, well, it's going to be all x greater than 0. The range will be all y. And let's see if we can graph that and see if we were right. Y equals 15 log x. Y equals 15, so we're just putting the number of 15 there. We're going to delete that one, so we're only looking at the one we want. Okay, so looking at this, we said there was 1 x-intercept at 1. Very good. We said that there's no y-intercept. Looks like no matter how much we go, there's no y-intercept. We said the domain, x had to be greater than 0. We said any y ever. Looks like if you kept going, it's going to keep increasing. Okay. And I think that was all the characteristics we saw, wasn't it? Yeah. Oh, and behavior. We got that as well. Okay, let's try this next one. Y equals -4 ln to the x. So we alluded to it, but that -4, how is that going to affect it? We're just going to skip ahead and graph this. So to find ln, it's down here, ln x. And let's graph what that guy looks like. Okay, we're zoomed out a whole bunch. So now, instead of being increasing, you'll notice that this function is decreasing. You'll notice that the the x-intercept is still 1. We have no y-intercept. Our domain is x is greater than 0. Our range is all y. Our end behavior, since we're reading from left to right, now it's from 1 to 4 instead of 4 to 1. So that's the only change, is now it's decreasing. Okay, I want to skip ahead to one of the questions. Let's see if I can find it. Oh, where we match. Okay, so match each graph. Here we have something exponential, exponential, and then those logarithmics. So if we remember exponentials cross the y. So these are going to be our exponentials. And we know our y-intercept. This one is 2, and this one's maybe 5. So remember, that's that value of a. So this one must go here because of that 2, and that crosses at 2. Because this is 5, that must match to that. Okay, now these two ones, we have one that's going to be increasing and one that's going to be decreasing. Well, this is decreasing. So that guy goes there, and this is increasing. So really quite simple, actually. So again, if you want to turn to this page in your textbook, this kind of gives you all that key information you need. The case is whether it's increasing or decreasing. Remember, it's the a value that tells you that.